Good morning, students. Today we are to see about the temperature control system in detail. Okay. So here, this temperature control system, we have a LM35, that is your temperature sensor. So this LM35 is a precision integrated circuits temperature sensor whose output voltage is linearly proportional to the Celsius temperature, and it measures the temperature in electrical output proportional to the temperature in degrees Celsius. So these three pins, that is, one is your voltage pin, second one is your output pin, third one is your ground pin. This diagram is a temperature sensor. Okay. Next is why the LM35 temperature sensor. You can measure the temperature more accurately than thermistors, and also the sensor circuit is sealed and not subjected to the oxidation. Then the LM35 generates a high output voltage than thermocouples and may not require the output voltage to be amplified. So we go for LM35 temperature sensor. Next is your interfacing LM35 sensor with the 8051. So the main principle of the circuit is to take the analog temperature and convert it into digital values and display the digital values in on your LCD or a 7-segment display. So this is the basic block diagram of your temperature control system, where you have an LM35 and ADC and a microcontroller and an LCD. So interfacing LM35 with 8051, the temperature sensor is interfaced to the 8051 via ADC. So here the LM35 generates a 10 millivolt variation to its output voltage for every degree Celsius change in temperature. Okay. So the output of the temperature sensor is analog in nature. So we need an A to D converter for converting an analog input to its equivalent binary output. So the ADC 0804 converts the measured temperature output voltages from the LM35 into a digital signal, then handled by 8051. Next is your ADC 0804 is the analog to digital converter. So this is your 8081. You have two clock oscillators. So here from pin 10 to 17 you perform all data operations, and P2.7 is your INTR, and 2.5 to 2.6 read and write operation is performed, and clock in and clock out you have V in positive and V in negative, and you have a VCC for supply voltage and V reference and the ground and the chip select signal. And after the INTR has become low, send high to low pulse to RD pin to get a data out from the ADC 0804 IC chip. So here the ADC 0804 is connected to the port 1 of 8051, where read, write and INTR of ADC is connected to P2.5, 2.6 and 2.7 respectively. So the analog input can be applied to V in of ADC. So here write operation is for start of conversion. So write operation is initiated until it reached the desired value. End of signal is conveyed. So INTR is for end of conversion. This is the overall temperature control system. So where here your sensor is connected to ADC, and that is connected to a microcontroller and LCD. LCD is meant to for display the value in the digital form, and here the ADC performs where it has an reference voltage until the input reaches the reference voltage value. The operation is performed in the loop, and when the value is converted, INTR sends a signal to end of signal as a to end of conversion to the controller. So this is a basic block diagram of a temperature control system, and if you have any clarity doubts related to this topic, you feel free to contact me. And also you can design various systems using this temperature sensor. For example, if you are designing a temperature, that is, if you are designing a temperature control system, that is something that you need to on and off a heater from the place where you are. so that you need to set the temperature. For example, the heater need to be heated till 40 degrees Celsius. So the 40 degree Celsius is continuously monitored from the place where you are, and report to you. And that is continuous monitoring is said to be your start of conversion operation. So until the temperature value reaches to 40 degrees Celsius in the heater, it automatically turn off the system, so that the INTR provides an end of conversion signal, so that the heater is off from the place where you are in a remote place. So this is an example of a data acquisition system, simple example of a data acquisition system. So you can design and develop any project, any application with the help of this data acquisition system. It is your the creativity is, there is no limit for your creativity. So when you are designing a system, you have to need to form a basic block, and you have to develop your applications. If you have any clarity related to this topic, feel free to communicate with me.